In problems 42 through 53, we're going to be using the vertex formula of a quadratic in order to find some kind of maximum value. And so the first word problem we have in 42 is just throwing a stone in the air, and we want to use the given function to figure out how many seconds it takes your stone to reach its maximum height, and then what that maximum height is. So this function right here is an upside down parabola, and this is what we're really finding right here, that ordered pair at the top, using the vertex formula. Instead of an x, the variable is t, and that just stands for the amount of seconds that has gone by. And so when I find t, I am finding the t amount of seconds that your stone has reached its highest point. And then s of t is going to actually give me that max height that your stone has. Okay, so we're just going to do negative b over 2a. My b value is 60. And my a value is negative 16, and then that reduces to 30 over 16, which is 15 over 8. And then you can decimalize that if you want to. It's 1.875 seconds. The only problem with putting it in a decimal form, that answer in decimal form, it just takes up a lot of room when you're substituting it back into the function. So I'm going to leave it as a fraction when I substitute in. And it doesn't really matter. You can put in the 1.875. I just know I'm going to be out of room. So I think I'm actually going to scoot down here underneath anyway, just to give myself some more space on this video. So it's negative 16 times 15 over 8 squared plus 60 times 15 over 8 plus 30. And again, I'm only leaving it as a fraction because I'm just going to be out of room here when I try to write in the decimal. Okay, so we have negative 16 times 15 over 8 squared plus 60 times 15 over 8 plus 30. And you get 86.25. feet. Okay, so the ordered pair would be 1.875 seconds to get a maximum height of 86.25 feet, and that's just the vertex of the parabola above. The first coordinate is going to give you the seconds that go by in order to get the second coordinate's maximum height. Okay, and all the problems in this section are done pretty much the same. In 44, we have a rocket, and they give us an equation that tells us how high the rocket will be after a certain time. And so we're just going to, once again, figure out that maximum height of that rocket using the vertex formula. So I'm going to plug into negative b over 2a. So we have negative 150 over 2 times negative 16. A negative divided by a negative will be positive, and then I'm just going to go ahead and reduce 150 by 2, which is 75 over 16. I don't even know if that reduces. I do not think that reduces. So I'm going to see what that decimal is. I'm probably not use the decimal because of the fact that I'm going to run out of space here in my video. I won't have enough room to write it down nicely, so I'll leave it at 75 over 16. And I just want to sneak a peek here. Okay, so that can't really be reduced anymore. So 4.6875 seconds, if you really want to see it decimally. But like I said, as I plug it into the formula, I'm going to leave it like a fraction. I just won't have enough space here to write it down. Okay, so we're going to find S of 75 over 16. And that is going to equal negative 16 times 75 over 16 squared plus 150 times 75 over 16 plus 40. I barely have enough room to even write this down. Okay, let's go ahead and substitute that. Negative 16 times 75 divided by 16, that whole thing squared, plus 150 times 75 divided by 16, and then plus 40 on the end. And that gives us 391.5625. And we can round that up to 391.6. 391.6. Okay, so what we have just found is after 4.66875 seconds, our rocket has reached its maximum height of 391.6 feet. Okay, for number 46, we first need to write our function before we can use the vertex formula. And what we're trying to do is maximize the area of this garden, given that we have 32 feet of fence to work with. So let's go ahead and start putting some dimensions on our garden. We are going to be cutting off a certain unknown amount for the first side, and we'll call that X. And because we're using the same amount on the other side, we'll also call that X. And then what's going to be left over for that remaining side once we cut off those first two amounts of fence is going to be 32 minus 2x. X amount plus X amount is 2x. X plus X is 2x. So the leftover expression that we'll use for this side here is going to be 32 minus 2x. And then our area is of a rectangle is length times width. Our function, our area with respect to whatever x we cut off is going to equal then my length, which is x, and my width, which is 32 minus 2x, my length times my width. And then you can go ahead and distribute. If you are going to use negative b over 2a, then your function has to be in standard form and you have to have it distributed out. If you want to use your graphing calculator, then you don't have to distribute anything out. You just put that original expression into the calculator, but you need to pick off your a and b if you're going to use the vertex formula. Okay, so once you have your function created for your area, that's our going to calculate the area based on whatever x amount we cut off. Now we're going to find the maximum area, which will be given by the vertex of that parabola that that function makes. Okay, so let's go ahead and figure out what x is. X is equal to negative b over 2a. And then now that I have my function in standard form, my b value is 32. My A value is -2. Negative divided by a negative is a positive, and 32 divided by 4 is 8. So cutting off a length of 8 for that first cut is going to maximize the area. So our length is just that first x value. And then our width is going to be 32 minus 2 times x, which is 32 minus 2 times 8. And 32 minus 16 is going to be 16. So the dimensions are going to be 8 by 16. This problem here we've done before, but not with -b/2a. We've done it with the graphing calculator and our max-min feature, actually our max feature. Okay, so we have water on the one side of the corralled area, so we don't need a fence there. Hopefully the cows aren't just going to jump into the water, and that keeps them nice and contained, and you need only fencing in these other red sections here. So let's go ahead and figure out how we should cut up that fence in order to get the biggest area possible. Well, you have 240 yards of fence to start with. So the first cut will be this side right here, which is going to be some x unknown amount, and then you have to make the same cut 2 more times because you have 3 sides of that fence exactly the same. And then 1x plus 1x plus 1x is 3x. So that's how much you've used so far, 3x. And the leftover amount for that other long side is going to be that 240 yards minus the 3x that you initially used. So 240 minus 3x. And then once again, it's just area. Area is equal to length times width, the area of a rectangle. And if we write it function style, we're going to use the expressions off of our picture. My length is the x shorty side here, and then we'll make the width 240 minus 3x. And I know I have a couple of extra x's on that problem, but we're only worried about the length times width to figure out this area on the inside. The other 2 x's that we have in that picture are just to help us build the correct expression for our width side. So really you're only using the x and the 240 minus 3x. And then you're going to distribute, and you get 240x minus 3x squared. And then we'll write that in standard form, because if we're not using our graphing calculator and we're using -b/2a to get the vertex, then it needs to be in standard form so you can figure out what your a and b is for the formula. Okay, so x is equal to -b/2a. That's actually representing our length. And my b value is 240. And my a value is -3. Negative divided by negative will be a positive, and so we have -240, positive 240 over 6, and then 6 into 240 is going to be 40. So our length is our x value, which is just 40. And our width is equal to 240 minus 3 times our x of 40, which is 240 minus 120, which is going to be 120. And so this problem is asking us for the actual area, and I can figure out the area 2 different ways. I can just take my 40 and substitute it back into the formula, but since I already figured out the width anyway, I'm just going to multiply 120 by the 40. And then my area is going to be 4,800 yards squared.